Hello, this is Mary James with Passive House Accelerator, and thanks for tuning into this special bonus episode of the Passive House podcast, recorded live at the Passive House Canada conference in Victoria, BC. And I'm sitting here with
Patrick Ropple from Evoke Buildings.
And who has been part of a very interesting study on embodied carbon and assessing it and the methodologies that are available to us right now to try and understand the implications of our choices. So that's how I'm summarizing the study, but can you tell us a little bit more, first of all, what you do at your firm and how you got into doing this study?
Our firm we kind of started 3 years ago. We're a new firm, and there's a bunch of people that have been around for 20, 30 years, decided to kind of like-minded people to come together and kind of push the industry forward a bit from, we have people that do energy modeling, but also from a building science perspective. So our specialty is kind of the building envelope. And now we're about 20 people. And part of some of the work that we do from my kind of previous employment and that is to do kind of research kind of things. One of the things that I'm known for is kind of thermal bridging calculations. So started with ASHRAE research project and kind of led into the building envelope thermal bridging guide and tools around addressing thermal bridging. So when it came to embodied carbon, kind of people talking about, we did all this stuff with energy efficiencies for whole building energy analysis, but then also thermal bridging was a big piece of that, and changing the code is when you're layering on the embodied carbon aspect. It saw a lot of similarities to what energy modeling was kind of 20 years ago, where there was a lot of inconsistent kind of information coming out. One consultant would tell developer one thing and then someone else would tell me everything. It was really kind of confusing, and people didn't have a lot of faith in analysis in what was being done. And part of it was they were overlooking thermal bridging, and the kind of path forward for net zero buildings is you have to calculate doing thermal bridging calculations comprehensively. So when we saw the embodied carbon stuff, and it's very complex subject, because there's a lot of different factors at play. We're talking a little bit of the stuff, even like emission factors, like how much does any building in a particular grid contribute to greenhouse gases is not an easy kind of calculation and whatnot. But what we did, because of our background, where we did all these projects where we're used to looking at a complex subject and putting it into simple terms and being able to put the data in a way that people can understand it, but also use it in practice where it's not too onerous. We saw a lot of similarities with the embodied carbon. So we got this study from BC Housing, basically on our reputation for what we've done in the past for whole building energy analysis and thermal bridging calculations, and saying we could do something similar for embodied carbon. We can take this seemingly complex subject that everyone's talking about and kind of boil it down to some ways that people can actually do something on projects, whether it be some design guidance, some high-level things of these of what actually matter on projects, and then not kind of get lost in the weeds of trying to make one thing look better than the other. Just put the thing out in an objective way.
As you said, there's so many pieces to an embodied carbon calculation. They all depend on the EPDs, the environmental product declarations. And yet when you dive into the details of what the EPDs are saying, there's, as you were saying, there's a lot of confounding variables in there. So can you give one example of that?
There's several, and a lot of this stuff where we were trying to account for is dealing with manufacturers, and then saying how, kind of explaining how those numbers come from one and different from another. And one of the topics that come up, which some of the protocols don't account for, is recyclability. So I know in our analysis, we used kind of a standardized value for aluminum that made any aluminum system that we looked at look really bad. But if you had a grid, if it was processed like, say, here in BC, which is a really clean grid, and you account for all the stuff, it would actually, the number would be much lower. But the fact of the matter is on projects the way it currently is you can't necessarily get that better product. Someone maybe never wanted to produce it yet because they're not willing to pay more money for it, or it might just be cost effective to do on any different projects. So then you're potentially over accounting for how much that particular component contributes to the overall embodied carbon.
As you did point out, I think you were saying that for bigger projects, and your study was focused on
non-combustible buildings.
That you might have more weight when you're ordering.
And that's the only way. So like right now, the way I look at it for embodied carbon is it's just building capacity. We're going through the process and that. But once people get familiar with that and then start demanding it, that creates a value to it. And then the manufacturers will respond. But because of, there's just like a lack of data for EPDs basically. And then things are just evolving a lot of times. It's hard to get, you don't have a lot of information available for what you actually want to use on a particular project. So that while industry kind of builds up, kind of creating all that data, I think a lot of that stuff will kind of sort itself out. And then I think the next stage would be that you start pushing for people to kind of do better kind of thing, come up with better things. And it's kind of like we were talking about it earlier. I did this study with another guy, Randy Van Straten from Belly. He's actually one that did all the embodied carbon calculations. And we were talking about that topic about demanding it kind of thing, and who should pay for EPD. Should it be government or individual manufacturers? And the way it worked out for thermal bridging calculations is the government paid for kind of standardized things here and set the kind of the benchmark. And then you as a manufacturer could come in and say, this is how I'm better than everybody else for the benchmark. I think that's the kind of the model that it probably evolved to, is that you set these kind of benchmarks that it levels the playing field, and then everybody else comes in and shows how you could reduce it, and it kind of evolves that way kind of thing.
And as I said, we're in Victoria, BC, and many members of our audience may not be familiar with, part of the push to do this is there is legislation in Vancouver, right, that addresses embodied carbon. Can you just briefly summarize what that is?
Yeah, so what was happening is Vancouver pushed through a lot of stuff for energy efficiency. They put the step code in, and then they started to recognize is, well, if we're going to net zero ready buildings by 2030, and we also have a clean grid and kind of cheap power, we've kind of done everything that you could do on that front to reduce emissions. And then once you've reduced that load so much, then they recognize that embodied carbon is a significant part. So they decide to tackle that next kind of thing. And they just started introducing kind of requirements for embodied carbon, where the first stage is just basically kind of reporting what you're using, getting people used to it. It's a similar analogy to the step code. Is the first step was you had to do thermal bridging calculations, and then the next step is that you actually had to reduce the loads and everything.
Right. And I loved your point that energy efficiency still really matters, as long as you're doing it well. Could you just talk about that a little more? Yeah,
so that's one of the things is, because we have a bunch of our partners are working on new construction projects, and other people are doing embodied carbon calculations, and it's kind of have this feedback loop. And then I heard some people in some projects were using less insulation, and they're pushing it because of embodied carbon perspective, which makes no sense, because you have a certain level of insulation for not only energy efficiency, which actually part of the demand side management for our grid in BC, because basically we're electrifying buildings and we're also electrifying cars or transportation and all that stuff. So you have to keep the loads down and kind of have that responsibility of keeping everything as low as possible so you can basically electrify more industry. But anyway, so then you see these people like kind of the pendulum swings a little bit too much where they're just focused on electrifying and not putting enough insulation, which is not a good thing. You have to look at it from a big picture perspective. And that's why we have these codes kind of thing. Because if you had to look at everything at a payback, here in BC we have a mild climate and we have cheap power and it's clean. Like a lot of those measures don't pay off from building to building perspective. It's a bigger picture thing.
That bigger picture includes a suite of co-benefits.
Yeah, exactly. Yeah. So the co-benefits is if resiliency. So if there's a power outage, like people can have comfortable conditions for a longer time. One thing that's really playing out here now in BC is with the wildfires, and we had the heat dome a couple of years ago, is that it's becoming, it used to be really mild and like 25 degrees. Oh, so, for American audience, and it was really comfortable thing. But now our summers are not becoming as comfortable with just the outdoor air quality. So that it starts putting in perspective. You kind of want heat pumps with cooling, and how do you do that where they have lower capacity and make sure that you have a comfortable indoor space to facilitate all that? It means like you need a certain amount of insulation, you need a certain amount of window performance to make all that stuff work.
And I understand your study is it's not quite out yet. It will be coming out later in the summer, correct?
Yeah, so basically we're finishing up. There's been a few reviews and we're just finishing that part of it, which we are planning to have that done by the end of the month. And then there's potentially more reviews from the client, BC Housing, and might be some other things with their communications department that I can't tell you exact date, but I would like to see it out like end of the summer, early fall.
And if somebody was looking for it, they would find it through BC Housing? Yeah,
so BC Housing has a lot of good resources if you want to check it out. They have a thing called Research Center, and even the thermal bridging guides are all there. Years ago, we did a low teddy guide, showing how you would get basically passive house ready buildings, kind of the detailing and all the stuff to do that. So there's that and many other studies on there. They got a great site.
Great. Thanks so much for stopping by and talking with us.
Thank
I
you.
appreciate your time.